Hello friends. In today's lecture, we see one example on total derivative. In last lecture, we have seen that the theorem on directional derivative. Directional derivative is equal to the total derivative of the function. Okay, directional derivative du f of a is equal to t of a. Du f at a is equal to t of u. That means directional derivative of the function is equal to their total derivative. Okay, now how to find total derivative of the function, and using that total derivative we have to find directional derivative of that function. Okay, so we consider here one example. Look at the example. Evaluate directional derivative of f of xy. We have to find directional derivative of that function f of xy is equal to x square plus y square at the point 1 minus 1 in the direction is minus 3i plus 2j using total derivative. That is, we have to find directional derivative of the function in the direction of minus 3i plus 2j using total derivative. So here we have to use that theorem, directional derivative of the function is equal to its total derivative. That means we have to find first total derivative of the function f of xy. Okay, so let us start. We have to find t du f of a is equal to 2u of u. हे आपल्याला फाइंड आउट करायचं आहे. We have to find directional derivative. For that we have to first find t of u. First we have to find total derivative of the function f of xy. Now what is f of xy? The function is x square plus y square. We have to find total derivative of that function. In last lectures we find or we solve some examples of finding total derivative using the definition. Same way, here we find total derivative of the function f of xy is equal to x square y square. For that, we take one point A, which is a1, a2, and the point H is h1, h2 belongs to R2. Then our function is R2 to R. So there these 2 points are in R2. So a plus h, which is a1 plus h1, a2 plus h2. A plus h means addition of these 2 points a and h. A plus h, coordinate wise addition, a1 plus h1, a2 plus h2. Okay, f of a plus h. Now why we find is f of a plus h? Since we have to find total derivative, and for that total derivative f of, we have to find that f of a plus h minus f of a minus t of h. Okay, for that purpose we find here f of a plus h. Now now f of a plus h means f of a1 plus h1, a2 plus h2. Our function is f of xy is equal to x square plus y square. That means first coordinate square, a1 plus h1 square plus a2 plus h2 square. Now a1 plus h1 square is a1 square plus 2a1 h1 plus h1 square. a2 plus h2 square is a2 square plus 2a2 h2 plus h2 square. Simply squaring using the rules of expansion. Okay, now f of a. F of a. F of a means f of a1 a2. F of a1 a2. That means here value of x is a1, value of y is a2. So from our function that f of a1 a2 is a1 square plus a2 square. So we have calculated f of a plus h and f of a. Now consider f of a1 a plus h minus f of a. Now f of a plus h is a1 square plus 2a1 h1 plus h1 square plus a2 square plus 2a2 h2 plus h2 square minus f of a, minus f of a. Sign will changes, minus a1 square minus a2 square. That means here is a1 square minus a1 square plus a2 square minus a2 square will cancel, and remaining 2a1 h1 plus 2a2 h2 plus h1 square plus h2 square. Okay, so we calculated f of a1 a plus h minus f of a. Now for the differentiability we have to define the linear transformation t, which is from R2 to R. T of h is equal to, h means h1 h2, since the point h in R2, h ha R2 चा point आहे. So t is the h is the point having the coordinates h1 h2. ओके, सो वी डिफाईन इयर टी a1 h1 h1. आता हे कशातलं डिफाईन करायचं असतं, तर जे आपण एफ ऑफ ए प्लस एच मायनस एफ ऑफ ए हे जे काही फंक्शन आलेलं आहे यातलाच एक आपण पॉईंट टी ऑफ एच डिफाईन करतो, जो मी तुम्हाला सांगितलेलं आहे की जे ए आणि एच यांच्या कॉम्बिनेशनमध्ये असतील त्या टर्म्स लिनियर ट्रान्सफॉर्मेशन म्हणून डिफाईन करायच्या. सो हिअर वी डिफाईन 2a1h1 plus 2a2h2 is T of H. Value of T of H is 2a1h1 plus 2a2h2. Okay, now we use differentiability since we have to find total derivative. That is, we have to prove that this function is differentiable at a. So here we use definition of differentiability. Okay, so by that definition, for epsilon greater than 0, there exists eta greater than 0. There exists a linear transformation T from R2 to R जे आपण डिफाईन केलेलं आहे, such that norm of H is less than delta. Norm of H means the coordinate H1, H2. That means norm of H is less than delta, that is square root of H1 square plus H2 square is less than delta. Okay, we have to consider this mod and we have to show that this mod is less than epsilon. Okay, since we have to show that the function is differentiable at e. So we consider here the mod of f of a plus h minus f of a minus t of h upon norm h. सबस्टिट्यूटिंग व्हॅल्यूज एफ ऑफ ए प्लस एच मायनस एफ ऑफ एची व्हॅल्यू आपल्याला माहिती आहे, ती आपण सबस्टिट्यूट केलेली आहे इथे. ओके, मायनस टी ऑफ एच व्हॅल्यू ऑफ टी ऑफ एच इज -2a1h1 -2a2h2. दॅट मीन्स दिस 2a1h1 2a2a1h1 2a2h2 2a2h2 will cancel and remains only h1 square plus h2 square. Here modulus of h1 square plus h2 square upon norm h. इथपर्यंत आलोय आपण. नाउ नॉर्म h इज इक्वल टू व्हॉट? नॉर्म h इज इक्वल टू स्क्वेअर रूट ऑफ h1 स्क्वेअर प्लस h2 स्क्वेअर. नाउ सो हिअर वी गेट दिस x अपॉन रूट एक्स या फॉर्ममध्ये आहे. पण रूट एक्स हा कसा लिहिला जातो? रूट एक्स इंटू root x into root x upon that root x. So this root x and root x will cancel and remains only root x. Okay, same here, h1 plus h2 square upon square root of h1 square plus h2 square means h1 plus h2 square is equal to square root of h1 plus h2 square into square root of h1 plus h2 square. ओके, स्क्वेअर मल्टिप्लिकेशन केल्यावर स्क्वेअर रूट कॅन्सल होईल आणि यांचं एकच नंबर येणार, रूट एक्स इंटू रूट एक्स upon. So one term will cancel and remains only square root of h1 square plus h2 square. Okay, but that square root of h1 square plus h2 square is less than delta. Already is less than delta. So here we choose delta is equal to epsilon. Choosing delta is equal to epsilon, we get that modulus of f of a plus h minus f of a minus t of h upon norm h. This term is less than epsilon. This indicates that our function f is differentiable at a. याच्यावरून आपल्याला आपण इथे प्रूव्ह केलं आहे our function f is differentiable at a and the total derivative of the function, that is derivative of the function is equal to its total derivative. त्या फंक्शनचा डेरिव्हेटिव्ह म्हणजेच त्याचा टोटल डेरिव्हेटिव्ह. आणि टोटल डेरिव्हेटिव्ह काय घेतला होता आपण? 2a1h1 plus 2a2h2. So total derivative of the function is 2a1h1 plus 2a2h2. ओके, इथपर्यंत कळलं आहे? ओके, now using that total derivative we have to find directional derivative of the function. Okay, we have to find directional derivative of the function using total derivative. Now total derivative is calculated. आपण total derivative calculate केलेला आहे. आता हा directional derivative कुठल्या पॉईंटला फाइंड आउट करायचा आहे? It is given at the point A 1 minus 1. We have to find directional derivative at point 1 minus 1 in the direction of -3i plus 2j. म्हणजे आपल्याला ए हा पॉईंट मिळालेला आहे. आता आपल्याला तो यू हा व्हेक्टर युनिट व्हेक्टर फाइंड आउट करायचा आहे, त्याची डायरेक्शन दिलेली आहे. सो लेट यू बी द युनिट व्हेक्टर इन द डायरेक्शन ऑफ -3i plus 2j. वी हॅव टू फाइंड दॅट व्हेक्टर. वी हॅव ओनली गिवन द डायरेक्शन. सो युझिंग दॅट डायरेक्शन वी फाइंड द व्हेक्टर यू इज इक्वल टू -3i plus 2j अपॉन स्क्वेअर रूट ऑफ -3 स्क्वेअर प्लस 2 स्क्वेअर. त्यांच्या कॉर्डिनेटची ॲडिशनने त्याला डिवाइड केलं की आपल्याला तो युनिट व्हेक्टर यू मिळतोय. सो वी गेट हिअर -3i plus 2j अपॉन स्क्वेअर रूट ऑफ 13. दॅट मीन्स हिअर एक्स coordinate is -3 upon √13, y coordinate is 2 upon √13. So now we have to find a directional derivative of the function f at point A 1 minus 1 and in the direction of u. Okay, now using that rule we know that directional derivative du f of a is equal to t of u. u काय आणि h काय? h म्हणजे तो डायरेक्शनच आहे. du f of a is equal to t of u. मग तो u म्हणजे ते पॉईंट कोणते आले तर -3/√13 2/√13 दॅट पॉईंट आहे. अँड आपला टोटल डेरिव्हेटिव्ह काय आहे? अवर टोटल डेरिव्हेटिव्ह इज 2a1h1 plus 2a2h2. Substituting values of a1 h1 and a2 h2 here. 2 into value of a1 is 1, h1 is -3/√13, 2 into value of a2 is -1, h2 is 2/√13. So this multiplication is -6/√13. This multiplication is -4/√13. Denominator is same, so -6 minus 4 is -10/√13. That means directional derivative of the function is equal to -10/√13. So directional derivative of the function in the direction of -3i plus 2j is -10/√13. Okay, first we have to calculate total derivative of the function. Now total derivative is the derivative of that function is the total derivative, and directional derivative is equal to total derivative. Using this result, we find the total derivative or directional derivative of this function. Okay.